All right, guys, here we go. Last video for the week. Thursday, 10-8, assignment number 8, section 2.3, rate of change. Rate of change is technically the slope, but rate of change is really kind of the slope at any given point of the line. So we can find the slope or the rate of change for a curve, whatever it needs. So I'm going to step out of the way. You guys can pause the video and you guys can copy all this down because I'm going to go over it. And so I'll stop the video. All right, so hopefully you stopped the video to catch up with us. So basically what I did here is I gave you an input-output table, x, f of x. Don't forget f of x is the same as the y. I don't know why I have that there. Okay, so it's time versus temperature, or y versus x, or f of x versus y, meaning temperature is this way, time is this way. Time's always on the x-axis, guys. Okay? And all I did was say, okay, I input 0, I get 143. I input 2, I get 139.4. I input 5, I get 133.1. And I went all the way across. Now, if you look at this, it's not necessarily a straight line. We don't know that for sure. So, we have ways to tell or ways to compare. We really don't care if it's a straight line or not. Just as you guys get going, we don't care if something's a straight line. We can use rate of change to figure out what we need to know. So y equals mx plus b is just it's something that's super helpful, but it's not the end-all be-all. Slope, or the rate of change, is the end-all be-all. That's the one you need to know. So rise over run, the formula, or whatever you want to call. So we're going to compare the overall average rate of change. Overall means the whole thing. So from 0 to 12 minutes, okay, or seconds, or whatever I've decided to label it. And we're going to compare that rate of change to between 5 and 8, these two. And what interval is decreasing faster? So let's tackle this. So rate of change is the change in y over the change in x. So I'm going to take the first one. This is the overall. And I am not going to give you the formula y2 minus y1 equals, over x2 minus x1. I don't use that formula. I just use what it says here. I need to find the change in y over the change in the x. This is how I do it. So, my rate of change, I don't even write slope anymore. My rate of change is going to be, my first one, 143.6 minus my second one, 118.4 over the first x value, 0, minus 12. I need my calculator. I don't know where it's at. It's going to be some number. I'll use my computer. Sorry about that, guys. So we have 143.6 minus 118.4. 25.2. So I have 25.2 over negative 12, which is approximately, it's a little bit bigger than 2, so let's say it's approximately 2.1. There's my calculator covered, but there's no calculator. All right, so approximately 2.1. That's the overall rate of change. So now let's do between 5 and 8. So this is my rate of change between 5 to 8. So I know now that I'm going to start with 5. So my rate of change is the change in y's. The y value, or the f of x value at 5 is 133.1. So we're right here. And then at 8 it's 126. We're going to minus 126.6. My first x value is 5. 5 goes with 133. 5 goes with 133. And then 8 goes with 126.6. 8 goes with 126.6. So again, I'm going to get a negative 3. And then I got to figure that 133.1 minus 126.6. 133.1 minus 126.6. 6.5. 6.5. So I'm going to have to figure out exactly, because these are pretty close right now. So let's figure out exactly. So 6.5 divided by -3. 2.16. So this is approximately -2.167. All right. Now let's do that one. 25.2 divided by 12. 2.1 exactly. Wow, that was a good estimate. 2.1 exactly. So negative, sorry. So here's the idea. Which one's bigger? Which one's steeper, decreasing faster? This number is a bigger negative number, so this one is decreasing faster than the overall point. So the point here is decreasing faster than the overall. Okay? So that's how you find rate of change. Rate of change is the change in y, the first y value minus the second y value over the associated x value minus the last one. You do it for any point they give you, so you can find it out whatever, any way you want. It's a lot easier to do it as an output table. You can graph it if you'd like, but always make sure you do rate of change. And then they have one more thing, and you guys have seen this multiple times, and it's if they give you an equation. If they give you this equation, let's say, I'll make one up here. Let's say they give you an equation, -3y plus 8x equals 10, and they go, oh, find the slope. There's a couple of little shortcuts that I know what to do, but if you don't know what to do, just solve for y. So -3y, I'm going to subtract the 8x over here, so I get -8x plus 10, and then I'm going to divide by -3, and I divide by -3, and I divide by -3. Doesn't really matter. So my slope is this one right here. So my rate of change is whatever's next to the x once I solve for y. That's my rate of change. So my rate of change is equal to 8/3. All right, guys? All right, so that'll get you going on assignment 8. Just a quick introduction. You have no more videos for the week, and have a great break.